Hey there, my name is Rohit Kumar, and today we are going to discuss a very important topic, that is object-oriented programming. So first thing first, that why do we need object-oriented programming? How it is so important? And when we discuss the concept of object and class, how they are related, and how frequently do we use or do we see these sort of concepts in. So we'll see all these concepts one by one, and we'll start with the very basic concept of what. So when we think of this particular thing, that what, then the question comes that is there any system that is being called a object-oriented programming system? And if yes, then why? So any system that is encompassing these properties, as you can see over here, these many properties, if any system is having these, the object, class, inheritance, polymorphism, abstraction, and encapsulation, then that particular system is going to get called as object-oriented programming system. Now, what are these properties and how they are supposed to get changed over the period of time? Let me tell you in short. So the object is anything, any entity that you are seeing around you is an object. So when we say any entity, so let me tell you that entity is something that is having some sort of properties or attributes. So suppose there is a particular kind of channel and there is a system. So one system is communicating with the other system. So here you have one sort of system, and let me show you better on. So suppose here is your one system, and here is another system, and both these systems are contacting with each other through some communication medium. Okay, so it is system one, system two. So if I say in this particular medium that what is the object, so your system one is the object, system two is the object, and this communication medium, it is also an object. So this is one way of communication, means one path or one single link or cable. Suppose this is the secondary path or single link which is coming through a third system S3, and this is another path which is coming through S4. So in this way, if you see, now there are three links, three possible paths, and there are five links. So one, two, it is one, it is two, it is three, it is four, and it is five. Total five links, because this system must be connected with this, then this, and like this. Okay, so five links, three systems. Here you can note down five links, three systems, and I think it's done. Yes, five links and three systems. And if we say path, yes, if we say path, then how many paths? Three paths. Okay, because direct, upward, downward. So in this way, you can see that this, how many objects are here? 5 plus 3 plus 3 means in total 11 objects are here. Okay, but how many classes are here? 1, 2, 3. Okay, so there are 3 classes but 11 objects. So in this way, I hope you have understood that what is the definition of object and class. Means when you are taking a single instance of something, then that is known as object. But when there is a whole collection of similar type of objects, then that particular collection is called as class. So object is nothing but a particular instance of class. So when we understand both these concepts hand in hand, then only we are able to understand them better. Now moving on to the concept of inheritance. So when we say inheritance, so inheritance means that whenever some class is inheriting the properties of another class. So suppose there is a class C1 and there is another class C2. Okay, so C1 is the superclass and C2 is the subclass. Like here, if I say C1 is parent, C1 class is parent, and C2 class is a parent can be a mother or a father, like this. Okay, so these two types are instances of C2 class, and this is a C1. So here parent is going to have some properties. Okay, and mother and father are going to share that particular property. So this C2 is going to inherit some or all the properties of C1. So C1 is going to be a superclass, okay, or the higher level class, and it is going to be a kind of subclass, means the lower level class. So in this way, the process of taking some properties from higher level class is known as inheritance. Okay. So like in real world, we do see that you are inheriting something from your parents, like you do inherit some properties or something like that. Then that is the sole concept of inheritance. Now moving on to the other concept, that is polymorphism. So in real world also, we do see these sort of things, means something is doing multiple things depending on the context. Okay, that is polymorphism. So coming to the literal meaning, people do define the meaning of polymorphism, that it's a combination of poly plus morphism. So polymorphism means the morphism is defined as the ability to take multiple forms, to take multiple forms, and poly means multiple. So when a particular function is going to have, sorry, here it is, ability to take some form, and here poly means multiple. So means when we combine these two, it becomes the ability to take multiple forms. So there is a function, or there is some operator. Suppose there is a function. That function, depending on one context C1 and depending on other context C2, it is behaving different. Here it is working like an addition operation, suppose addition function, and here it is working like some other operation, like a function like concatenation function. Okay, so that is the depending on the context, that what type of function this particular function f is performing. Okay, now coming to the other form of polymorphism, that is the operator. So operator overloading comes to picture. Here it is function overloading. We will discuss all these concepts in detail in the coming lectures. So operator, this is function overloading, which is a form of polymorphism. Second comes the operator overloading, which is also a form of polymorphism. In operator overloading, again the same thing. Suppose there is a operator which is performing a particular function depending on context 1 or context 2, means depending on a particular context, the operator is behaving differently. So that's why, suppose there is plus. So same thing. Sometimes it may work like a addition, or sometimes it may work like a concatenation. So this particular thing is being used inside a particular function, then you may achieve this sort of overload. So that is the sole point of function and operator overloading. Moving on to the next thing, that sorry, not the next thing, some of the concepts are pending. So we have seen the polymorphism, means whenever something is doing multiple things or the different things depending on context. And there is a concept of abstraction. So when we say abstraction, so it is very important thing, because in real life also we do have this very prominently in different contexts, that we are going to abstract something, or we are going to see some abstract form. What is abstract form of something? So abstract form means not a clear form. Okay, means a kind of vague form. So when we say abstract form, means the vague form, that some of the details are hidden. Now, why it is important to hide some of the details? Because they may lead to the kind of security in the application. So you never want to disclose, or you never want to expose all the details to third party or the users or somebody else. So that's why abstraction is quite important. So many times you give the lower level abstraction to the user, or the higher level abstraction to the user, depending on that type of user or depending on the requirement. So abstraction is nothing but that you are showing some or the required details to the user, and that you can achieve with the help of the kind of settings that you are having inside the class. So inside class, you can have the concept of abstraction. When we will move on to the practical aspects, we will see all these things very clearly. Just for the sake of understanding as of now, you just simply remember that just representing something in its vague form is abstraction. Then you have the last concept, that is encapsulation. So encapsulation means the simple thing that like you do have a capsule sort of thing. So there a normal capsule is a composition of two parts. So similar way, when you have a particular capsule like a structure, suppose this is a class. Okay, this is a class C, and it is having two particular things. One is data and second is function. So this function is going to behave differently depending on the type of data that is provided to it. So there might be multiple functions, there might be different type of data available inside a particular class, but in general, there are two types of things. One is data, second is function inside a class. And this whole thing is kind of encapsulation, means it is a capsule, and the process of putting data and function together, it is called encapsulation. Okay, so that is the full funda of encapsulation, means you are putting together multiple things, and then depending on the requirement, you are defining your functions based on the data. So that is the encapsulation. So moving back to the slides, and we are moving further, coming to this particular definition, that any system that is using all these properties, that is object-oriented programming system. Move further, the second question, very clear, that we have understood what is the object-oriented programming system, but why do we use it? So when we come to the object-oriented programming, before it, usually you must have heard of procedure-oriented programming. So procedure-oriented programming means procedural programming that thinks of that there is a single sequence of control, means the control is going in a specific direction with a specific flow, and you are executing all the things. So there is means there are some global data, and those global data are supposed to get used inside some functions depending on the requirement, and the functions may have their local data also. Okay, so similar thing, suppose in a C program, C is a procedural programming. Okay, so C programming, and here you may have in object-oriented C++, Python, Java, etc., etc. Okay, so we are just taking a single example of C, and you may take C++. So then you are starting from main, and then you are performing the things in a specific fashion, means you are going line by line, and then you are performing all the things in a particular procedural way. But in C++, you are defining the classes. So you are defining the class, then class C, then you are defining its structure, which is a combination of data and functions, means the encapsulation and all. And at what level you are defining the things, that is the abstraction. Then how many classes you are defining, the inheritance comes into picture, how you are defining the functions and operator behavior, that is polymorphism, etc. So all those properties will come into picture here when you define all the related things in a program. And at what level you are defining the things, it depends on the complexity of the program. So ultimately, all the things are coming together. And here, when you have defined the class C, then you will make its object, and then you will use that inside a main function. So you will define the main function, and then you will define some object of this particular class. And when you will define the object of this particular class, like you are defining C1, C2, okay, then you will use a particular kind of behavioral function that is associated with this particular class to use these objects in a particular way. So here you are having this class C, you may have other classes also, but the point is that the behavior of functioning is quite different. Here from main, the control is going in a straightforward direction, but here the control may move from one way to another. For example, the object C1 is calling something which is available inside object C2, then object C2 is calling something which is available in C1, and there might be the use of some functions which are working or behaving differently depending on the context. So in this way, the relationship is quite jumbled. So here you can see that in object-oriented programming, the data and function and their relationship is not as straightforward as you see usually in processor. Okay. Other than these, there are obvious benefits of object-oriented programming based on the related properties, like the majorly based on the inheritance and encapsulation. Additionally, inheritance and polymorphism. And additionally, you do have the encapsulation, means encapsulation, and because of this, you have the kind of abstraction. And then you have the other things, means depending on these particular things, you may define that at what level you are implementing the kind of access control mechanism inside your system, etc., etc. So all those things are not part of this introductory lecture. So we'll discuss them later. Moving forward, that we have understood what, we have understood why. Now the thing is that how to design object-oriented programming system. So quite simple and very straightforward process. Just start within a particular way. You should start from an object concept, and then you should move like this. So when you think from a concept point of view, usually you think from a concept. You usually start from object, but when you actually practically code it, then you firstly define a class, because without defining the class you cannot define the object. So in this way, usually this is a bit contrast over here, that usually we think about object first but we define the class first. Okay, but without thinking you can't code. So obviously you should think of an object that you need in your program or something like that. Then you define the related class. Then you define the inheritance process if multiple classes are there and they are inheriting something from each other. Then you move on to the polymorphism. If you are having some functions or the operators which are working differently depending on your requirement, then you have the concept of abstraction, means how you are defining the level of details inside your class and how the functions are using all those things. Then you have the encapsulation, but again the same thing, that it may be debated that encapsulation and abstractions are the part of class definition, so they may come at the very early step. So all these things are not in a straightforward way, that firstly you do this, then this, then this, then this. You may have a different order also, but usually you define them according to your requirement. There is no specific way of defining all these things. But if we say a general system, then you can go like this. Now moving forward, we have the concept of class and object, because we have understood all the basic concepts. But when we say the class and object, so what are the things? So here in the figure form, you can see quite easily that there is a class. Here you have this particular class. Now there are some fields. What are the fields? Means these are the data and these are the functions. Okay, so as I told you, that data and functions combination is nothing but class. Okay, so that is your class. In class you have some fields, the like the name, the type is string, then size, type is integer, then you have the methods rotate and move. Now you have defined three objects of this particular class. Okay, the name of this particular object is object 1, size is 2, second is object 2, size is 3. You can see that these fields, these properties, these attributes are same with respect to all the objects. Why? Because every object is an instance of class. So all the properties of a common of the classes are going to get shared, because all the objects are of the same class. Okay, so in this way, you can see that only the values are different, and then depending on the requirement, you can define these values. Now, based on the methods uses inside these objects, you can manipulate all these values. So that is the whole concept behind class and object. Moving forward, we have the class objects example in real life. So in real life, usually when we discuss, because theoretically discussing all the things is very good, means it looks very easy. But when coming to real life, so it's difficult to correlate. So here it's also quite easy. You can see that there is a class model. Suppose there is a chassis or the bare structure of a car. Okay, so there is a headlamp, then here are tires, then there is a front window, then there is a back window, then the outer chassis, etc. So all these things are present in every car. But what quality of tire, the headlight, the etc., the engine, etc., all these things, the horsepower of the engine, etc., etc., all these things are different when you go for a specific version of a car. If you are going for an Audi, Nissan, Volvo, Rolls-Royce, etc., etc., then all these things are different depending on the company's uses of the components and their specific specification with respect to a particular object or the model. Okay, so these all are objects, but all these objects belong to a class which is car, because all these vehicles, all these objects, the Audi, Nissan, Volvo are going to share the properties of a general car. Okay, moving forward, when we come to the concept of object-oriented programming, the thing comes to the mind that there are some governing principles with respect to every system. So what are those principles? So we have already discussed these principles in the form of attributes, but let me correlate again that encapsulation, as I told you, that object only exposes the selected information. Usually this is the abstraction which becomes possible with the help of encapsulation, because you put all the things inside a particular class. So suppose this is a class, and then this is function and data, and here you are encapsulating, putting together all these things. So our object only exposes the selected information. So that particular selected information, this is the information, this is the data, and you are exposing with the help of function. Okay, so encapsulation, at what level you are putting all the details inside this, and this is a kind of means encapsulation and abstraction kind of correlated, highly correlated, and hides the complex details. So one way of writing the other thing means you can say that there are two ways of writing the same thing. So when you are exposing the selected information means you are hiding some of the related information. So in this way, here you can see that you are hiding the complex details to reduce the complexity. But I have taken this from this particular source, sixth reference number 6. I have taken this figure. So here they have defined the encapsulation, but in my opinion, usually the simple definition of encapsulation is just that you are putting the related information together, means the functions and the data. The most simple definition encapsulation, that you are putting something together, making a kind of capsule of something. Then if you are hiding the details, that is abstraction. When you are inheriting, means the entities, means the objects are taking properties from other entities, then those, that is inheritance. And when the entities are behaving in different way, depending on the context or depending on the region of interest, then that particular thing is polymorphism. All these things will become very clear when you go for the practical uses. So don't worry if you don't get it as of now. Later on in the coming lectures, we'll see all the things. Then coming to the basic example, we have already discussed this example, but why we are discussing again? Because here we are having some pseudocode in the form of methods and attributes. What are attributes? Attributes means the basic data. So here you can see the fuel and the max speed. Two variables are defined with the help of attributes. Then with the help of methods, we are defining some functions. The refuel, get fuel, set speed, get speed, and drive. Okay, so all these things are related to these attributes, and then with the help of attributes only you can define some functions, because obviously functions might not use the data, because there might be some functions which are not at all using any data, like they are printing only some information or something like that. But usually the functions depend on the data, because they take the data, they print the data or do something like that. Then only the concept of class comes into realization. Moving forward, coming to the realistic example, because here we were saving the kind of conceptual example. So this particular thing was only at conceptual level. Okay, we were having this thing at conceptual level. But when moving on to the real world example, so here we have the kind of real example. So this is your real example. There is a dog. Now dog, it's a kind of class, but at the same time dog is an object also. So if you said dog, then again you may find the different categories of dog, that it's a Doberman or something like that. Okay. Then if you are saying it's an object, then obviously it's a living object. It's not dead. It's not something non-living entity. Okay. So it's an object also. Same thing. Same time. At the same time, it is having some methods. Means it can run, it can play, it can eat, and it is having some attributes that it has a particular height, has a particular weight, and got some food to eat. So all these things are related to dog. So here the only thing is this, that a real life example, when we see of something, then something may consist of multiple things. It is not always that something is an object, that it cannot be a class. It can be both things at the same time. Okay, so be vigilant and see carefully that how you are going to define your system, how you are going to define an object-oriented programming system, because one thing is obviously related to other in some way, but at what level you are defining it, at what level of abstraction you are going to define all the things and their behavior and the functions, that is quite important. Moving forward, coming to the pseudocode example, so here you can see that there is a definition class. Pseudocode is nothing but a code form which is very close to the actual code form. It is not the actual code. This code, if you write on to any editor, it is not going to get compiled, because it is not the actual code with respect to any programming language. It is just a close form or the very actual form of real code. So it is related to the real code. You just need to change some of the things and it will become the actual code, or it gives you the very clear understanding that how our actual code is going to look like. Okay, so here it is the class circle. Then there are two parameters, radius and color, and these are the type of these variables, double and string, and these are the values 1 and red. Okay, then there are some related functions. So here you can see that class name is circle, and again here the function is circle, which is constructor. Now what is the constructor? We'll see in the coming lectures. Means just for the auto initialization of some object, because when you create an object of a class, automatically some of the properties or some of the values get inherited or initiated with respect to that particular object. So that is done with the help of constructor. So it is default constructor because there is no parameter over here. And again, here is a circle. There is a parameter r type of double. It is a parameterized constructor. Again, there is a second constructor where they are having two parameters. So depending on the number of parameters, you can have multiple parameterized constructor, etc. Then you have the get radius, get color, get area, and the type of these functions. Here you can see that double, string, double, all these things are defined. Now that is the class definition. So it is your class. Now coming to the attribute. Oh, sorry, objects. So it is object 1, object 2, object 3. So object 1, object 2, object 3. So here C1, C2, C3. Now the radius is defined as 2 and color is blue. Means the default values 1 and red. These are not inherited here. Okay. Here you can see 2 and red. Okay. So again, the default values are not inherited. And here you can see the 1 and red, and 1 and red you can see. So all the both default values are inherited over here. Okay. So in this way, you can see that when you create some object later on, default values do come in the objects, but you can modify depending on your requirement. And if you don't want to, it's your wish. You can continue like that. These are some of the basic functions which are related to these objects, and you can use these functions with respect to any object, and you can change things whatever way or whichever way you want to do it. So that's all for this particular lecture, and all these references are here, which I used. Means the data that I used in this particular presentation come from these particular sources. If you're interested, you can go to the links and you can fetch more information. Coming to the conclusion, if you have some doubts and if you want to find more videos, you can follow me on the YouTube. You can get the related videos over there. And we are going to start some fresh series with respect to fresh topics. So slowly over the period of time, you'll find all the related details at YouTube channel. Additionally, if you have any doubt or query, please do contact on the LinkedIn, and you can comment down below in my YouTube videos also. And please do criticize, because of that only some level of improvement will come into my videos. So thanks for watching again. Have a good afternoon.